Determine whether the given series converges or diverges. Let's take a look at example 1. Suppose we have the summation from n equal 1 to infinity of 1 over n cubed plus 8. We know that n cubed plus 8 is greater than or equal to n cubed. So 1 over n cubed plus 8 is less than or equal to 1 over n cubed. And this is for n equal to 1, 2, 3, etc. And so we also have to note that 1 over n cubed plus 8 is greater than or equal to 0 for these same values of n. We need that for the comparison test. Now, the summation from n equal 1 to infinity of 1 over n cubed converges by p series. P is equal to 3, that's the exponent right there, which is greater than 1. Therefore, the summation from n equal 1 to infinity of 1 over n cubed plus 8 converges by the comparison test. Let's take a look at example 2. Suppose we have the summation from n equal 1, well in this case n equal 2 to infinity of 1 over the square root of n minus 1. Okay, we're going to apply the comparison test again. But look at how this one works. The square root of n minus 1 is less than or equal to square root of n. Notice how I made the denominator bigger. So 1 over the square root of n minus 1 is greater than or equal to 1 over the square root of n. And this is for n equal to 2, 3, 4, etc. And we know that this is greater than or equal to 0. Now, by the way, the square root of n is the same as n to the 1/2. So those are the same thing. The summation from n equal 2 to infinity of 1 over n to the 1/2 diverges by p series. P is equal to 1/2, which is less than or equal to 1. Therefore, the summation from n equal 2 to infinity of 1 over the square root of n minus 1 diverges by the comparison test. On number 3, suppose we have the summation from n equal 1 to infinity of n plus 1 divided by n square root of n. Okay, now n plus 1 over n squared of n is greater than or equal to n over n times the square root of n, right? Because isn't n plus 1 greater than or equal to n? That's true, right? Now, notice how the n's cancel, and we're left with 1 over the square root of n, which is just the same as 1 over n to the 1/2. And this is true for n equal to 1, 2, 3, etc. And remember, that's greater than or equal to 0. The summation from n equal 1 to infinity of 1 over n to the 1/2 diverges by p series. P is equal to 1/2, which is less than or equal to 1. So therefore, the summation from n equal 1 to infinity of n plus 1 over n squared of n, that diverges by the comparison test. So notice how n plus 1 over n squared of n is greater than or equal to 1 over n to the 1/2. So we're comparing it to something that we know diverges. That's kind of the idea. And then on number 4, suppose we have the summation from, this is n equal 1, by the way, to infinity, of 9 to the n over 3 plus 10 to the n. So 3 plus 10 to the n is greater than or equal to 10 to the n. 1 over 3 plus 10 to the n is less than or equal to 1 over 10 to the n. And then what I'm going to do is I'm going to multiply both sides by 9 to the n. That is legal. So in other words, up here, I'm multiplying by 9 to the n on the left side, and I'm going to multiply by 9 to the n on the right side. And so 9 to the n over 3 plus 10 to the n is less than or equal to 9 to the n over 10 to the n, which is equal to 9 over 10 raised to the n power. And remember, 9 to the n over 3 plus 10 to the n, that has to be greater than or equal to 0. And this is true for n equal to 1, 2, 3, and so forth. So the summation from n equal 1 to infinity of 9/10 to the n converges. And this is a geometric series with the absolute value of r equal to this 9/10, which is less than 1, which I fully acknowledge is a mouthful. So the summation from n equal 1 to infinity of 9 to the n over 3 plus 10 to the n, this series converges by the comparison test. So the first 4 examples, everything's the comparison test. Number 5. Suppose we have the summation from k equal 1 to infinity of the cube root of k divided by the square root of k cubed plus 4k plus 3. Okay? Now, the cube root of k is k to the 1/3. The square root of k cubed plus 4k plus 3 is greater than or equal to the square root of k cubed, which is equal to k to the 3/2. And then 1 over the square root of k cubed plus 4k plus 3 is less than or equal to 1 over k to the 3/2. And then what I do is I multiply both sides by k to the 1/3. That's what I have in red down here. Because my goal is I have my number or my sights set on this piece. For large k, 3 is not going to contribute very much, and neither is this term. It's cube root of k over the square root of k cubed is what I'm trying to look at primarily. And so that's what I'm going for, if you notice. Notice how k to the 1/3 over square root of k cubed plus 4k plus 3 is less than or equal to k to the 1/3 over k to the 3/2. Over here, so 0 is less than or equal to k to the 1/3 over square root of k cubed plus 4k plus 3, which is less than or equal to k to the 1/3 over k to the 3/2, which is equal to 1 over k to the 7/6. And don't get hung up there. If I take 3 over 2 and I subtract 1 over 3, right? I'm going to multiply over here by 3 on top and bottom. And over here, I'm going to multiply top and bottom by 2. And so this is 9 minus 2 divided by 6, 7/6. And so this is the summation from k equal 1 to infinity of 1 over k to the 7/6 that I care about. That series will converge by p series. P is equal to 7/6, which is greater than 1. So the summation from k equal 1 to infinity of the square root, the summation from k equal 1 to infinity of the cube root of k divided by the square root of k cubed plus 4k plus 3, that'll converge by the comparison test. And that'll do it for this video. This is a video on the comparison test where we did 5 examples. Thank you.